Modified Gaussian integral x. Okay, so basically we are doing a series of videos where we are doing the modification. We are basically solving the modified Gaussian integrals. You all know that the Gaussian integral is this thing, integral from 0 to infinity with the power minus x squared dx, which has a pretty cool answer, that's root pi by 2. Yeah. And in search of this coolness, we are also solving other problems like integral from 0 to infinity of e to the power minus lambda w of x squared dx, or may it be integral from 0 to infinity of e to the power minus ln square of x dx. And not just this, we also solved for integral from 0 to pi by 2 of e to the power minus sine square x dx. And also other trigonometric stuffs, other inverse trigonometric stuffs. We solved many of them, and now this is the 10th video and we are on this. Yeah. And yeah, if you want to look at these videos, I will link the playlist over here and also in the description box. Okay, so you can check that. And for this video, let's go into this. And of course you know how to begin this problem. Yeah, and let's just try to find the indefinite integral first. Indefinite integral. And the way we begin this integral is from the use of substitution, that y equals to arc sine of x. Yeah, sorry, arc cos of x. Yeah, and with that we get cos y equals to x, and that means dx is equals to minus sine y dy. Yeah, then we have integral e to the power minus y square, and then dx is equals to minus sine y dy. Okay, so now we will try to express the sine y in terms of e from the complex definition of sine function. We know that, like, from this formula e to the power I theta equals to cos theta plus I sin theta, we can derive a formula for sine. That is, sin theta is equals to e to the power I theta minus e to the power minus I theta by 2i. Yeah, you can use this formula. If you use that formula, we get integral of e to the power minus y square, and then minus of e to the power iy minus e to the power minus iy by 2i dy. Basically now we can multiply e, and that makes things simpler, so that's why we did this. Now after this we have 1 by 2i outside, and e to the power minus minus plus. Let us use this negative sign to make this plus and this minus. Okay, yeah, that's why y square, and this one minus iy, and so again now minus e to the power, let me erase this thing, and e to the power minus y square plus iy. I think you have understood that I use negative sign to make it plus, and this one minus, and dy. Now the next thing we should be doing is to complete the square, because that will simplify things. Yeah, let's complete the square. Integral of, we have e to the power minus of y square plus iy plus I by 2 whole square minus I by 2 whole square. Yeah, and then minus e to the power minus of y square minus iy plus I by 2 whole square minus I by 2 whole square. Yeah, and then dy. Okay, so now after that we have 1 by 2i, and the integral of this thing over here. How do we write this? This is minus of y minus, sorry, plus I by 2 whole square. Yeah, and the minus minus will be plus, and then this will be I square 4, so that's minus 1 by 4. and then minus, this will be e to the power minus of y minus I by 2 whole square minus minus plus, and then I square by 4 is minus 1 by 4 dy. Now take the e to the power minus 1 by 4 common, so e to the power minus 1 by 4 by 2i, and then integral of, now this is e to the power minus y plus I by 2 whole square minus e to the power minus of y minus I by 2 whole square dy. Yeah, and now how do we do? So for this we can use the OR function. Let me now share about the OR function. Basically OR of x is defined as integral from 0 to x of e to the power minus t square dt. Yeah. And if we have integral from, let's say, a to b of e to the power minus t square dt, this can actually be written as integral from 0 to b minus integral from 0 to a. Yeah, that's why this will be OR of b minus OR of a. And we can see that OR function actually also acts like the indefinite integral too, because this is OR of b minus OR of a. We can also say that indefinite integral is also the OR of t, and then we can evaluate this at the limits. Yeah, so this says that OR function can be used as an indefinite integral too. Yeah, now so let's use this as indefinite integral over here, and that gives us e to the power minus 1 by 4 by 2i, and this is OR of y plus I by 2 minus OR of y minus I by 2. Now okay, now we have to take it back to the substitution y equals to r cos x. Now let's use that substitution, y equals to r cos s. That gives e to the power minus 1 by 4 by 2i OR of cos inverse x plus I by 2 minus OR of cos inverse x minus I by 2. Yeah, and now after this we have I over here. Now you can use this I to change ORF to ORF-I. Let me show you like why and how. So basically our ORF-C function, our ORF of function is defined as integral from 0 to x of e to the power minus t square dt. Yeah. Similarly, our ORF-C function, complementary error function, is defined as integral from x to infinity of e to the power minus t square dt. Yeah. Similarly, our imaginary error function is defined as integral from 0 to x of e to the power t square dt. There is no negative sign over here. Yeah. And from these definitions, you can derive yourself easily that ORF-C of x is actually equals to 1 minus ORF of x. Yeah, and similarly, ORF-I of ix is I times ORF-I of x. Yeah, and similarly, ORF of minus x is minus ORF of x. That is, this is odd function. And the last one is ORF-I is also odd function. ORF-I of minus x is equals to minus ORF-I of x. You can derive these 4 formulas that will be helpful in solving problems, and this can be derived from definitions itself. Yeah. Now with that formula, what we can do is we can take out I common. Yeah, e to the power minus 1 by 4 by 2i. Now we can take the I common and write this as 1 by 2 minus I cos inverse x. Yeah, and then minus, also take out minus I common from here, and that gives us 1 by 2 plus I cos inverse x. Yeah. Now first of all, over here this will be I times r5 of x. Yeah, e to the power minus 1 by 4 by 2i. This will be I times r5 of 1 by 2 minus I cos inverse x minus. Now first of all we can use the orness of r function, so minus will make this sign plus, and then I of orf is I times r5, I times r5 of 1 by 2 plus I cos inverse x. Yeah. And now uh, this I cancels out, so this was the simplification that I wanted, and that's why we made this change. To the power minus 1 by 4 by 2 or 5 of 1 by 2 minus I cos inverse x. Oh wait a minute, I have made a mistake. I will tell you. I'm so sorry for that. I made this mistake in the previous video too, and in this video as well. Okay, the mistake over here that I made is, this is not r function, this is root pi by 2 times r function. This result is root pi by 2 times r function, so this one is also multiplied by root pi by 2. This one is also multiplied by root pi by 2. Yeah, similarly all these results. This one is orf x times root pi by 2, orf c times root pi by 2, orf I times root pi by 2, and these are correct results though. Also over here, this is not just orf, this is this times root pi by 2, 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 this times root pi by 2. I'm so sorry for that. I always forget this root pi by 2. I don't know why. Okay, now I think this is the indefinite integral. Now let's check if this is correct or not from alpha, and then we will find the definite integral then. Okay, root pi by 4 and then 4th root of e. Okay, so root pi by 4 and then 4th root of e, yeah, in denominator, and then this thing, r phi of 1 minus I cos inverse x plus r phi of 1 by 2 plus I cos inverse x. Yeah, that's the thing over here as well. R phi of 1 by 2 plus I cos inverse x on the 2 minus. Okay, now fine. Now let's evaluate. Now let's try to find the definite integral from 0 to 1 of e to the power minus cos inverse x whole square dx. Yeah. Now let's try to find this. For that, let's evaluate this at 0 and 1. And so let's see what do we get. This is root pi by 4 4th root of e. Yeah. And then this is at 1, cos inverse 1 is 0, so this is r phi of 1 by 2, and this is also r phi of 1 by 2, yeah, because cos inverse 1 is 0, minus at 0 cos inverse 0 is pi by 2, so r phi of 1 by 2 minus pi by 2i minus r phi of pi by 2, yeah, so 1 by 2 plus pi by 2i. Yeah, so this is the thing, and I think this, how do we simplify this? Can this be simplified? Root pi by 4 times 4th root of e, this is 2 times r phi 1 by 2, and then minus r phi 1 by 2 minus pi by 2i minus r phi 1 by 2 plus pi by 2i. Yeah, so I think, is this the answer? Let's check. Root pi by 4 4th root of e. Okay, so here's minus is taken as common. Let's also do that. Okay, so let's take the minus sign common, and minus root pi 4 4th root of e, and that leaves us with minus 2 or phi of 1 by 2 plus or phi 1 by 2 minus pi by 2i plus or phi 1 by 2 plus pi by 2i. Yeah, okay, so minus 2 or phi 1 by 2 plus or phi 1 by 2 minus phi by 2 plus or phi 1 by 2. Yeah, that's the correct answer. From the Wolfram alpha, we also found that answer. So this is solved now. We both the indefinite and definite integrals are correct. And now talk about the flow of the problem. We first started with this integral making a new substitution. Yeah, that was obvious. And then we tried to take it to the powers of e, because we already have e over here, and like only e will make things simpler. And then we completed the square, and over here we found that OR function will be helpful, and then we used OR function, and then we saw the relation between OR of c and OR phi, so that we can change it to OR phi function. Though OR of c wasn't necessary, but I did share about it. We changed it to OR phi to cancel the I over here, and my bad luck that I forgot with pi by 2. And then we got the indefinite integral, and then we substituted the values that got us the indefinite integral. So that was it. Hope you enjoyed this integral. Thanks for watching, and also check other videos on this playlist. Look forward to seeing you in the upcoming videos too.